Bismillahirrahmanirrahim. So this is our second week for the collaborative teaching between UiTM and UGM, University Gajah Mada. And last week, we already learned the fundamentals, the theory about socket programming, how we can exchange the data between two processes which may be reside on different hosts. So we can do inter-process communication using socket programming. So for this week, we will learn in more details regarding the socket programming that we can use to implement socket programming and the network programming. So like I said before, in major operating systems such as Linux, Unix, or even Windows operating system, there is a socket mechanism, right? So they can abstract all the lower layer protocol so that it become easier for us to do inter-process communication or to do communication over the internet, over the TCP/IP. So in order for developer to tap on that abstraction, right? So they will in the operating system. Maaf saya saya kena tengok belah tepi tu pasal saya kena sentiasa apa ni let in student. So maaf pasal ramai student boleh masuk. Alright, so again, how we going to use socket programming in operating system? So usually in operating system they will have a API, application programming interface, right? So that for example, if we are developing the program using C language, Python, Java, so or any programming language, so usually there will be a library. So for example, in C, there will be a socket library where there is a function where it will call the unique the socket API, right? So that is what we will learn today, right? More details about the API. Right, so what we'll cover today is first we will do some recap regarding the socket function. And the first that's mean in the socket function where we will create the socket, right? So kita akan buat socket tu. Okay, first we will create a socket, then what it will do, the process will be assigned with the file descriptor, or in this context, we usually will call it as socket descriptor. So they're basically just a number so that we can know the socket that we are referring to. So if, for examples, if in the process we create multiple socket, then there will be a multiple socket descriptor or file descriptor for the socket. And after we have created the socket, then after that we need to bind the socket into port number and also IP address using the bind function, so that we can call the bind API. And after that, after we have bind the socket to the port and IP address, we need to set the port to listening mode so that it ready to accept request from the client, right? So kita kena set the jadi ready lah. And after that, the server, so if we are creating a code for server side, then we will start to wait, right? So we will start to listening for any request from the client. So from our code, if let's say we detect there is a request from a client, so in order for us to make it to establish the connection, so we can use the accept function, right? So what happens is when we create an accept function, basically it will create another socket for that particular communication. Why? Because of course what we want to do is we have one server but we have multiple client, right? So of course, for example, if you are browsing the website, or for example you are transferring a data using FTP, usually the server will serve multiple client, right? So that's why every time the client do request a connection to the server, so the server will create another socket, another sub socket for that particular connection between client, for example, client A and server. So for example, if we have a client B, then there will be another socket descriptor will be created. So there will be a multiple socket. I will show you after this. And if we are creating a program for the client side, so what it will do if we are using the connect function. So what it will do, so maybe I can show you, maybe this will make my explanation become more clearer. Basically, we have already discussed this last week. So let me open slide first. Yep, here. So this is important, right? So please be focused on this. So can you see the image that I'm showing? Right. So here we have server and client, right? So here is where the interaction been done. So for example, here at the server side, if we are creating a program for the server, then like I said before, we first create a socket. Then after that, we will bind it to the port and IP address. Then after that, we will set the socket to listening mode so that it can receive connection from the client. And after that, it will start to listen to the request from the client. So now we will talk about the client. So the client, at the client side, first it will create a socket. Then after that, if it want to create connection to the server, so of course, because server is passive, server is just listening to the request. The active one, the one that initiate the connection. So for example, if we are using TCP, the one that initiate the three-way handshake is the client. So in order for the function that we can use to initiate the connection is the connect function, like I said before. So when what it do is it will send a TCP sync. Then what happened at the server side? So using a set function, so the server will accept connection, then it will create another socket for that particular connection. So if, for example, if we have multiple clients, then it will create multiple socket. Then once the three-way handshake, so for example, if we are using TCP, then what happen is when the three-way handshake already completed, so what will happen? We will first so the data transfer can occur. So it will be unidirectional transfer. So that means the client can send data using write function, or it can also read data from the server using the read function, and vice versa. So that means the server can do the same thing. So it can also send a data, and also it can it can read data from the client, right? So once for example, the data transfer or the communication session has concluded, so that's mean based on your design, maybe if one of the client or the server want to terminate the connection, so what we can do is we can use the close function, right? So the close function, what it will do is very important, so that it can free up the ports and also it can free up the memory. So if we doesn't use the close function, then it will waste. So that means the resources will not be released, and it will occupy the memory of your computer, right? So again, back to the slide. So that is what we will cover today. So all the function that I have talked about earlier. And we will also learn about the haston, anton, stonl, and ntohnl function. So this is what we call as endian conversion. Like I mentioned last week that in computer system, in computer architecture, there are two types of endianness. So for example, if we are using Intel-based computer, like 886 computer, so it will use Little Indian, right? But if we are using, for example, a Motorola processor, or we are using ARM, there will be option to process the data using the Big Indian format, right? But unfortunately, for if we are using socket programming, regardless of your platform, for example, if we are using Intel processor or AMD processor, so if we are using socket, then the socket programming must be implemented in Big Indian. So that's why we need to do the conversion. So the conversion will happen. We can use this function. So basically, this is host to network short translation. That's mean from Big Indian to Little Indian. Short, that's mean it is 16 byte short. MTOH, which is network to host conversion. So that's mean it is from Big Indian to Big Indian to the Little Indian. Short, that's mean 16 bit byte. And we have host to network long, STONL. This is host to network long. So that's mean it is from Little Indian to Big Indian, and it will use it will support long format, which is 30 up to 32 bytes. And this is network to host long, 32 bytes, right? And we will also talk about INET address, where how we're going to format the IP address in decimal notation, and we convert it into the Big Indian and also in the binary form, right? So this is what we will learn today, right? So I hope that you can focus yourself. So if you have any questions, so please do ask me. So for example, if I'm talking too fast, so if my explanation is not clear, so please do stop me. I will more than pleased to answer your question. Is it okay?
Okay, sir.
All
Okay,
right.
sir.
So we begin. Okay. Oh, sorry, nak tanya. Dekat atas ni saya ada macam bar. Kan saya pakai Webex kan, saya share screen. So the top bar tu saya nampak bar. So untuk kamu nampak tak perkataan application programming interface tu? Clear tak?
Nampak, sir.
Tak block Okay, right. Tak apa. So maksudnya saya je lah yang block. Okay. First, we learn about the API. So what is API? So apa yang kita cakap API? So what is API that we are talking about? Like I said before, API is a way, is an interface so that we can interact with the operating system actually. So in this context, we will interact with operating system, and why we are interacting with the operating system, so that we can request the operating system services. For these examples, we are requesting the socket services. API is not only we did not only limit the usage of API only for the socket programming. API is widely used anywhere in the developer world. For example, if we let's say we want to do some file manipulation. For example, if we want to open a file, or for example, if we want to delete a file, there is API for that. So operating system will have API for that. And for example, if we want, for example, to interact with hardware, especially when we want to interact, for example, with USB interface, or for example, maybe we want to interact with TPM, if you guys ever heard, the security module, right? So that is API for that, right? But for our case, we want to use the network adapter, the network interface, right? So if we want to use that, we will interact with the socket API. Most of the operating system will implement it. And even if we, for example, we are developing a web-based application, right? So nowadays, most of developer will create their own API so that their web system can interact with other web system. For example, a cloud storage services such as Google Drive, for example, right? So Google provide cloud storage services to the public, right? So anyone can use Google Drive so that they can store certain amount of data to the cloud, to the server, to the Google Cloud, right? So yeah, so we know Google Drive is very convenient. So for example, so we as a developer, for example, how we can integrate Google services, Google Drive into our website, or for example, our web services, for example, we are creating an app where we will facilitate classroom activity, for example. So we create a website for that. So if we want to use Google services to store the data for our web application, so Google has its own API. So for example, one of the Google Drive API. So anyone can use this. So maybe if you want to use it for your FYP for your final year project. So there is a site where it will document all the API which is available to the for example, if we see the documentation, so we can, for example, there is a example here. For example, if you want to upload file, so for example, if you want to make our website to upload file to these Google services, so this is example, right? So this is API using Java, and this is Python, and this is I think this is if we are using REST API. So this is just a pure HTTP, and for example, if we are using Node.js. So this is a different type of API. So the same concept apply to operating system, right? So for example, operating system provide socket services, file services, scheduling services, right? So if we want to use the services of the operating system, so operating system will have its own API. Okay, so using the unique function, so we can interact with the services. So clear about the API? So any question? Alright, so itu API panjang lebar cerita pasal API. So now API tu saya nak kamu faham pasal API ni dia bukan hanya apply dekat kelas ni. So bila later on when you learn a web programming class, when you attend web programming class, or for example if you are for example attending networking class, they will nowadays we will talk a lot about API. So please take note on that. Okay, so there is two type of socket like we have discussed before. There will be a TCP socket or UDP socket, right? So there is a difference. So if we are using the TCP, what it will do is like this, right? So for the server, we need to create a socket, bind, listen, accept, then read and write, right? So if we are decide to use UDP, which is the connectionless type of communication, some of the function will not be used. So what I can say is, so if we want to use UDP, yes, we for the server side, we need to create a socket, then we will use the socket function. Then after that, we will use the bind function. And after that, we doesn't need to listen or accept. That doesn't need, because there is no three-way handshake. So we can straight away read and write, okay? Because if we are using UDP, we doesn't create a three-way handshake. For the client side, it's also the same. So we will create a socket, then we just straight away use the connect function to establish the connection. So in here, in UDP, there is no accept function. So the client just send the data, and the server will just reply the data or send back the data to the client. There is no three-way handshake. Okay, and socket can be used for unicast IP address. So for unicast, that's mean for one-to-one connection. So you already learned this in TCP/IP class. So one-to-one, that's mean my PC, for example, if I want to browse the Netflix server, so I'm requesting from the Netflix server the video or the movie that I want to see, right? So the Netflix server will reply it only to me, right? So that is one-to-one communication. That is unicast. For multicast is for a set of destination. So usually multicast is used in the broadcasting industry. So for example, anyone here has IPTV at their home? For example, if your parent or you are subscribing to Unify, to the broadband services, did you guys notice that that is a set-top box given by the Telecom Malaysia? Do you guys ever see the set-top box? It's like this. Like this. You notice this, right? If for example, if you are okay, so how it works? So usually for this set-top box, right? So they work by using the multicast. Yep, they are using IP based, so that's why it is called Internet Protocol TV. But how it's work is it is using the multicast set of IP. So what it does, so maybe I can draw you some simple explanation here. Okay, let's see here. Okay, so for example, so if we are talking about unicast, right? So here is, for example, my PC, right? So for example, yeah, nowadays everyone is watching Netflix. So for example, we have Netflix server here, right? So this is in the most simple form that I can. So what it do is, so Netflix, it will have its own public IP, right? So the PC will request, and the Netflix will only reply back only to one host. Okay, so what they transfer is basically the movie, right? The video file. So if, for example, if we have multiple PC, multiple Netflix client, so maybe we have PC number 2 and so on and so forth, and number. So that means there will be a lot of individual requests, right? So for example, if we have for example, the movie file is so sekarang ni kalau 4K berapa dia punya file? Anyone knows? 3 gig lah. For example, 3 gigabit of 3 GB of movie file that you want to request. Okay, so 3 GB, right? So for example, here, if we have 100 client want to stream Netflix, so how many data actually been transferred over the network? So 100 times 3 gigs, so how many gig? We have 300 gig, right? Can you imagine how many data it is? Wasteful, right? So, but this is how Netflix work, right? So, but Netflix has other workaround that they do. They have what they call as caching server, as they have, content delivery network. They have CDN and so on. So that's how they can optimize the experience. So anyhow, from the network engineer perspective, this is wasteful, right? Because we are sending, for example, if this 100 client want to watch the same movie, that means the Netflix server need to send the file, the big file, 100 times, the same file 100 times, right? So do you understand this analogy? So ada 100 klien, 100 kali lah file tu di download. Betul tak?
Betul, sir.
Okay. Okay, so one way we can, make this more efficient. So what it does, we can use multicast. By the way, Netflix is not using multicast, right? So basically, Netflix is using Anycast. That is a totally different story. So maybe if later on you take, advanced network programming with me, maybe later on we'll talk about Anycast. So anyhow, to make this more efficient, right? So what Netflix does, not Netflix lah, I mean, other IPTV, for example, like Astro. Yeah, Astro is using multicast from my experience. So here, for example, if we are using multicast, okay, so we have your IPTV set-top box here, so STB, so the short form for set-top box. So this is you trying to watch football, so connected to the set-top box TV. So there is a different channel, right? So we have channel number 1 until channel number 100, for example. So what it does, so the set-top box will connect to the telco network. I mean, ISP network or telco network. Okay, so here we have the media server. Usually people will call it with many names, but one of the name that they call is media server. So in the media server, where all the content resides, all the file, all the video file, all the image, all the sound, everything, right? So what difference between the unicast and multicast? So for unicast, there is one-to-one communication, but for multicast, it is for one to group. So all of the user here, for example, if we have, okay, for example, if we have, for example, 100 subscribers, right? So we have 100 STB here, wanting to watch football, for example, right? So instead of one by one being requested, yes, they will request. So first, what they do, all of these client, it will subscribe to it will subscribe to the multicast domain. Multicast domain. So as a slide, usually the multicast network will start with 224 IP. So for example, here we have channel 1 with IP 224.1.1.1, or we have channel 2 224.2, sorry, .1.1.2, for example, so on until 100 channels, right? So all the set-top box does it will subscribe to multicast domain. So when the media server, so when there is a request for media server, so what media server will do, it will only send the file once. So for example, for channel 1, for the football, it will send the file only once to this channel only. So once anyone that subscribing to this channel will get the same thing. So that means the server doesn't need to send the file 100 times if we have 100 subscribers. So the server only will send it once. So for example, if the file is 3 gig, even though we have 100 subscriber, so it will only consume 3 gigabit per second bandwidth. Do you guys understand? There is a stark difference between unicast and multicast. So this is more efficient. So that means there will so we are not wasting the bandwidth because bandwidth are limited, right? So yeah, so that is multicast. So unicast, one-to-one communication. This is what we always done. If, for example, if we browsing internet or we are watching Netflix, and there is for in the broadcasting industry. So for example, if we are using set-top box, usually they will set up a multicast IP, right, for that particular for the TV channel, right? So they will use multicast. Okay. Okay, boleh faham tak tu? Any question so far?
No, sir.
Alright, so kalau dekat Malaysia lah, for Indonesia I'm not sure, but for Malaysia, for Astro, for Telecom Malaysia, this is the setup they are using lah, multicast. So anyhow, next we have broadcast. So for broadcast, this is direct and limited. So that's mean that for broadcast, for multicast, from one to group of hosts. So that's mean if the set-top box subscribe to channel number 2, so only this set-top box will receive the data. But for broadcast, the server will send the data to all hosts regardless of your group. There is no group. So for example, if here, right, I have my command prompt. I have ipconfig. So for example, my Wi-Fi here, my network, my IPv4 address is 192.168.0.196. So my subnet mask is 255.255.255.0, which is /24. So my network address is 192.168.0.0, right? So I'm part of that network. So you see here, we if let's say I want to send a broadcast network, a broadcast message. That means I want to send this message to all the hosts in my network, irregardless whether they subscribe or not subscribe. Then I will send it to my broadcast IP, which is 192.168.0.255, where all the 8-bit octet is turned on, right? So what it do when I send it to 192.168.0.255, basically I'm sending this packet to all the hosts in my network. So this is broadcast. Okay. So anyhow, I'm not trying to send this because what will happen? I will DOS myself. Faham tak? So masa saya akan buat di DOS, boleh saya hantar ni dekat rumah saya ni ada set-top box, ada router saya, ada TV, lepas tu ada apa lagi? Ada my wife laptop, tu ada desktop. So what happen is bila dia orang semua dapat, dia orang semua akan reply balik ICMP tu kepada saya punya PC. So PC saya tu nanti dia akan been overwhelmed with the traffic. So if I send this lah. So this is broadcast. So back to our lecture. And we have another one which is look back. So I think look back is where the local IP, which basically what we use is we want to test whether our TCP/IP stack or our network interface is working or not. So when I ping 127.0.0.1, basically I'm pinging myself. I'm pinging my network interface, right? So yep. So that is look back. Okay, so I'm like I said before, we have TCP UDP. So I think we doesn't need to discuss this. We already discussed this in the last class. So for TCP, we have reliable three-way handshake. UDP, we have in unreliable connectionless style of communication. Right, so this is the TCP segment. For example, if you are sending the TCP, like I have also show you last week using the Wireshark, right? So basically it is in the layered. So that means the upper layer protocol, the application data will be encapsulated in the transport layer protocol. Then the TCP protocol in turn will be encapsulated by the IP layer. Then the IP layer will be encapsulated by the data link layer, which is the internet. Then after that, it will send via the network, via the medium, whether it's wireless, 5G, wired internet, ones and zeros. So one it's already received by the destination. What it will do, it will decapsulate. It will open up back the internet, the IP, the TCP, and up until to the application, and it will send the data to the application. So that is how the TCP/IP work, right? So this is the header for the TCP. Yeah. So the data that TCP carrier here is the application data, the layer 5 data, right? For example, if you are writing the protocol for HTTP, then the HTTP data is being encapsulated here. Okay. Okay, so this is where we will start to learn how to use it programmatically. So first, like I said before, we will create a socket. So the socket is a function. So this is in C. So the socket function, there is three parameters that we can pass. We need to pass. First is the domain. Second is the type, and third is the protocol. Okay, and the socket function will return back the value, which is it will return the file descriptor or the socket descriptor. So it just a value like I'm showing you last class. Sorry nak tanya, saya ada tunjuk kan minggu lepas yang saya tunjukkan socket descriptor tu yang dia 01 orang dah ambil, lepas tu nombor 2, 3, 4 tu kalau kita create socket. Ada tak? Ada kan? So itulah, itu yang dia akan return balik. So if we want to refer to that socket, so kita boleh refer dekat dia punya socket descriptor tu, value socket descriptor tu. So anyhow, apa yang kita nak pass tadi, first is the domain. So domain ni dia is in an integer value, so kita mesti pass dia dalam integer value. And ini yang menentukan kita nak gunakan IP, kita nak gunakan untuk layer 3 protokol apa. So selalunya kita akan gunakan IPv4 lah. So kalau IPv4 selalunya kita akan passkan dia nombor, tak silap saya. Oh. Jelas ke? Boleh nampak ke tulisan ke besar sangat ke kecil sangat?
Jelas.
Jelas.
Baik. So saya nak buat. Ya, kalau kita tengok sini, so kat sini kita create socket sorry. FINet so kita kena pass FINet, bukan sorry. So FINet, so ni merujuk kepada IPv4 Dan kemudiannya kita akan setkan dia punya type. So dekat sini dia akan ada our style of communication, either TCP ataupun UDP. Selalunya dua tu lah. So kalau contoh kita available, kita nak gunakan TCP, so dia punya kita panggil dia sock stream. Dan if for example if we want to use connectionless type of communication, so kita nak guna UDP dan kita tulis kat sini sock dgram, datagram. So ni kalau sock stream ni saya menggunakan TCP. FINet, IPv4. So anyhow, okay, balik kepada dia punya domain ni, dia selalunya orang akan gunakan IPv4 ataupun orang akan gunakan INET6, which is IPv6. Soalan cepu mas, is there any other type of layer 3 protocol? If there is, can you name one? Anyone? Boleh tak namakan satu? Kalau lah you guys tahu. Anyone nak try? Selain daripada IPv4 dan IPv6. So ini common lah, semua orang tahu rasanya.
EMP.
Apa? EMP?
ICMP.
ICMP. Betul? Betul. Macam betul. Betul. Kalau kita nak create ICMP punya packet, ya betul. Kita kena pass itu ICMP. Tapi anyhow, ICMP pun dia work dekat IPv4 punya protokol. Okay, so apa yang saya refer tadi tu betul. Nanti kalau mungkin tadi yang tanya tadi sebenarnya dia pernah buat pun Okay, yes, betul. Kalau kita ICMP protokol, walaupun ICMP tu macam ping tu dia gunakan IPv4, tapi sebenarnya dia adalah dia tak ada apa layer punya protokol. Maksudnya dia punya layer atas tu bukanlah TCP ke UDP ke, tapi dia ICMP. Tapi anyhow itu nanti later on lah. Bila kita belajar advanced socket function kita akan tengok tu. So bagus, good answer. So anyhow, satu lagi yang mungkin sekarang ni pasal mungkin lama kita tak guna pun. Basically dekat global internet sekarang ni, basically itulah TCP/IP, kita gunakan internet protocol dan juga IPv6. Sebenarnya dulu ada company macam Apple for example, dia introduce dia punya own layer 3 punya protocol lah untuk buat network. Namanya Apple Talk. If you guys ever heard Apple Talk. Okay, so keluar cake tapi anyhow sorry bulan puasa keluar pula, tapi anyhow Apple Talk. This continued proprietary suite of networking protocol developed by Apple Inc. So ini adalah lawan kepada TCP/IP. Tapi of course kalaulah di hari tu global citizen dia decide tak naklah pakai TCP/IP, kita pakai Apple Talk. So that's mean mungkin kita kena bayar lesen kot. So maksudnya kalau kita nak gunakan internet, kita kena bayar lesen pula dekat Apple. That's why it more make sense kita guna IP, TCP/IP, which is open. Semua orang boleh guna. So ada satu lagi. Kalau you guys pernah dengar Novel. You know what? Novel protocol. IPX, SPX network, tak sure. Tapi dia adalah time ni company tu nama dia Novel. Dia keluarkan dia punya networking punya protokol juga. Dan for your information, IP protokol yang kita sekarang ni guna dia ada ambil some inspiration from the Novel. Dia adalah so anyhow dia take dia take some inspiration from this, tapi dia bukan dia lah. So now memang dia dah obsolete, so sekarang ni memang kita pakai TCP/IP. Okay, so anyhow I go back to our slide. So next is the protocol. So kita pass pula protokol. So protokol ni dia dia boleh dapatkan dia punya list ni So usually kita akan set dia sebagai kosong. Tapi anyhow kalau kita nak buat raw socket kita boleh tengok list of protocol yang dia support. So contoh macam jom kita tengok ada tak PC protocol. Tak ada. Kita tengok mana disimpan list tu. Okay, so boleh nampak ke manual yang saya tunjuk ni? So apa yang saya tunjuk ni untuk Unix, untuk socket API tu dia ada letak di punya documentation. So inilah yang saya buka ni documentation dia. So domain yang disupport AFINet, IPv4. Lepas tu kita ada AFINet 6. Lepas tu kita ada Netlink, X25. Ni Apple Talk tadi lah, tapi so far ni memang tak pakai lah. So ini yang dia support. Ataupun kalau contoh kita nak buat our own layer 3 punya protokol, boleh. Kita boleh guna raw socket ataupun kita boleh just kita guna je packet punya address family ni. Tapi jangan risau, jangan serabutkan kepala, don't worry. So what in this class the only thing that we will use is AFINet. Jangan risau. So kita guna AFINet je dulu so far. So mungkin later on bila saya revise balik syllabus ni mungkin kita akan buat start IPv6 lah. So nowadays semua pakai IPv6 kan. So anyhow satu lagi. For the type kita ada stream, TCP, UDP, DGRAM dan kita ada raw. Raw ni bila mana kalau contoh kita pilih tadi kita nak buat our own layer 3 punya protokol ataupun our own transport protocol. So kita nak buat sendiri our transport tu, kita boleh gunakan raw ataupun packet. Ni pun boleh. Sorry, dia dah obsolete. So basically kita guna raw je. Okay, tapi jangan risau dalam kelas kita ni dua je kita guna. Kita gunakan TCP, stream dan juga datagram. Dan seterusnya adalah dia punya type. So selalunya kita akan Okay, so untuk type tu, argument dia, kita boleh letak non-block ataupun this one. Tapi selalunya kita letak kosong sahaja. So kita letak kosong. Pasal kita tak guna all the advanced low level punya socket tu. So kita letak kosong. So jangan risau kan. So itu dulu. So kita akan letak, so macam inilah kita akan letak kosong. Like this one. Kita letak kosong. So ini first. So bila kita buat ni, kita dah create socket. So bila kita buat ni, kita dah dia akan returnkan socket punya descriptor tu dalam satu variable. So kita kena simpan lah, memang penting. So daripada socket variable ni, kita boleh do some manipulation. Okay, so boleh dulu setakat ni, kita create socket.
Boleh.
Sing ke nak saya cepat sebenarnya, ke sebenarnya kamu ni sebenarnya semua dah dekat diploma ke kat matric sebenarnya dah ambil socket programming. So sebenarnya benda ni apalah cerita. Nak detail Okay, okay, seterusnya okay, ni tadi saya dah tunjuk source stream, datagram. Alright, so seterusnya tadi we already create a socket. So now we need to bind it to the port and IP address. So ini analogi dia boleh baca sendiri, tapi saya dah terangkan banyak kali, even kelas minggu lepas. Port tu supaya kita punya komputer ni boleh ada multiple communication session. Kita boleh web browse, kita boleh ni. Dan IP address supaya kita boleh uniquely identify host dalam network tu. So that's why kita kena ada IP address. So ini analogi dia lah. Dia selalunya ni common lah kalau when we talk about networking, people will give analogy as a postman kan. Macam the postman want to send the letter to your house. So dia kena ada dia punya address, dia kena ada dia punya mailbox number. So sama juga, same analogy is being applied to TCP/IP. So saya skip ni. Okay, next, like we have talked about earlier, after we create the socket, we need to bind it. So how we going to bind it? We can use the bind function. So bind function. So kita panggil bind. So dia ada 3 juga parameter yang dia boleh terima. Satu, first, we need to set this we need to send the socket descriptor ID. So maksudnya contoh, we want to bind the socket socket number 1 ni kepada certain IP atau port, dan kita kena bagi dia punya socket descriptor. So kalau kita tengok dekat coding saya ni tadi, ni client, sorry. Patutlah tak make sense. Sekejap saya buka satu lagi. Server. Kat client tak ada bind Kat client tak ada bind. Tengok tadi saya tunjuk tadi, client tak ada bind. Okey, jangan risau, lepas bind ni kita rehat Tahu you guys dah mungkin berasap ke apa, tak apa, kita rehat lepas ni. Kita main satu game, lepas tu baru kita continue dengan soket-soket yang lain. Okay, let's see. Server side. Okay, so kita create socket dan kemudiannya kita akan bindkan dia. Okay, so dia ada 3 dia. Dia ada 3 function. Satu, kan kat sini ada variable yang simpan socket descriptor tu kan. So nampak, kita pass dekat sini. So pasal kita nak bindkan socket yang kita create ni ke certain IP. So kita letak socket descriptor kat sini. Dan second one is dia punya address punya ni. So dia terima the second type ni. Kita bukan hanya hantar address, kita kena hantar struct. So struct ni is a collection of variable. So struct, konsep dia struct So satu variable yang dia akan simpan banyak multiple value. So struct value. So dalam struct ni nanti kita kena declare, kita kena guna scene inet. So kita akan declare dulu dan kemudiannya dia punya size in byte. Size apa tau? Bukan size ni, size kita punya struct ni. So kalau kita tengok dekat sini, kita pass socket descriptor dan kemudiannya kita passkan struct. So struct ni saya declare dia nama variable dia server. So ni cara kita nak declare struct tu. So dekat sini dekat variable yang atas ni server. Nampak? Kita declare struct type dia sock header and in. So benda ni memang dah fix. Benda ni dia dah sebahagian. It's part of ARPA INET punya library. Okay. So sebelum kita boleh guna tu, kita kena declare dulu. So what it do, so server punya variable tadi, since kita gunakan struct, dia dot. So first kita akan setkan dia punya address family. So AF-INET, IPv4 lah, merujuk kepada IPv4. So server.syn header.s ni, so maksudnya ni kita ni kena hafal So ini kita merujuk kepada in any. So maksudnya kita akan bindkan dengan semua IP yang ada dekat server saya, dekat Ubuntu server saya. So contoh macam server saya ni dia ada EMP0S 3 interface. So I look back, termasuk look back. So kita ada 3 IP kat sini. Dia akan bind yang ketiga-tiga. Kalau if we want to bind to only one IP, then that's mean kita kena set lah IP kat sini. Instead of kita pakai in area any, tapi kita kena set IP address. Tetapi kita tak boleh letak macam tu saja. Kita kena convert. Kita kena convert daripada Little Indian kepada Big Indian. So itu later on. Nanti saya akan tunjuk example yang lain. So anyhow, for this, I am only binding. I'm binding this socket to all IP that the server have. So dia punya keyword dia in adder any, INADDR any. Dan seterusnya is the port. So now I want the server to bind to port 888. So since this is in the Little Indian, the socket requires Big Indian. So that's why kat sini ada function host to network short. Dia akan convertkan ni kepada 16 byte of addresses of Big Indian punya addresses. So daripada that one, after that saya pass kepada bind punya function ni like this. Kena ada pointer struct kena ada pointer. Ni kita pointer. Ini cara dia. Dan kemudiannya size tu yang kita refer ni, size is actually referring to the size of the struct. So we will use function size of. So by using this function will return back the value of the variable here. So dia akan return kan. So this is the bind punya function. Ada soalan tak? Any questions so far? So far so good? Because digest tak apa. That's why kita ada lab so kita tengok betul-betul. So anyhow, apa yang saya buat the if ni, right? So the if ni, so the bind and the socket, right? They will return back a value. If we see here, it will return a value. So for bind, the value that it will return is the status. So if the value is -1, that means the binding process failed. So selalunya, usually it fail because the port is already been used by other process. So maksudnya ada proses lain yang guna socket programming juga, it already bind to the same port. So itu selalunya fail. So nak test here whether it's fail or not. So what it will do is it will say that binding failed. So and after that I will send this return 1. That means this process will stop executing. Right? So inilah. Kalau kita punya socket tu fail nak bind, server tu tak boleh nak jalan lah. So that's why penting. So kita terus exit je program tu. Kalau bind to fail. Sama juga dengan socket. So selain daripada the return socket descriptor, kalau socket descriptor dia -1, -1, that means kita fail nak create socket. Mungkin because of various sebab, pasal atas banyak sebab lah. So sometimes because our operating system has an error, or maybe there is a permission error, macam-macam, right? So mungkin because of that we cannot create a socket. So tu dulu socket dengan bind. Right? Any question? Sebelum kita rehat. Okay.
Okay.
Alright. Okay, so jom kita main, let's play some simple game, you know, just to gauge your understanding about the unique API. So I have a Kahoot game. Alamak. Hold on, let me set up the Kahoot game. Okay. Okay, so jom. So let's everyone join this game, right? So before we take our break, so please enter www.kahoot.it and put this game pin. Join the game. Macam LTE lah, plastik hitam. What's up guys? Ini kayu amingnya. Okay, kita start Oh, VVV Osas. Alright. Okay. Which is not unique socket API function. Not not. Alamak, ramai salah. So bukan bound tak ada So tadi kita dah belajar, kita ada socket, kita ada listen, kita ada socket, bind, listen, accept, connect, receive, send. Bound tak ada. So far tak ada lagi lah. Bound tak ada. Bind ada. Next. True or false? IPv4 socket can use unicast and anycast address. Okay, jawapan dia adalah false So dia unicast, multicast dan broadcast. So tu difference sikit. Okay, so anycast ni IPv6, right? So itulah. Anycast IPv6 So sebenarnya dia multicast. So sebenarnya ramai salah ni sebenarnya. Right? So next. What is the characteristic of SOC diagram? Yap, so apa ni? Ramai salah juga. So SOC diagram ni dia merujuk kepada UDP So UDP, so that mean is unreliable type of communication. Tapi sebenarnya betul, yang connection ni betul. Ni saya salah, sorry. Saya tak betulkan lagi daripada semester lepas. Yes. Dua-dua ni betul. Unreliable dan juga connectionless. Dua-dua betul. Ni saya silap saya silap. So betul dua-dua. Okay. Next. True or false, we need to use bind if sending data. Jawapan dia kenapa false? Okay, dia sebenarnya yes. I know your argument is kenapa yes kita kena bind. But if we are sending data using UDP, kita just send je data. So we really doesn't need to use bind pun sebenarnya. Kalau kita just send saja. So tu nanti kita akan discuss lebih lanjut. So jawapan dia false. Yang tepat dia false. So I know why many answer true. Tetapi kena berhati-hatilah. So inilah contoh-contoh soalan yang keluar kat test nanti. So kalau kita nak apa ni, kalau kita gunakan TCP three-way handshake tu, kita guna bind. Dia sebenarnya wajib pasal bila kita nak send dengan receive, dia secara reliable. So anyhow, tak apa, ini no problem. Next. Which of the following is non-blocking function? Ni kalau siapa betul, hebat lah. Okay, jawapan dia adalah listen. So non-block, dia ada blocking dengan non-blocking. So blocking ni maksudnya adalah bila kita kita create a socket ataupun kita bind socket ataupun kita gunakan accept. Proses tu dia tak boleh nak buat benda lain tu. Dia tak nak buat benda lain. So that's why kita kena ada child process. Yang kita dah belajar 2-3 minggu lepas lagi. We need to create a child process. Because the process cannot do anything else because it has been blocked for that function. Sampai function tu habis dia. Tapi untuk listen tak. So listen is non-blocking function. Example of non-blocking function. So right. Apa nanti kita akan discuss lebih lanjut. So let's see siapa yang dapat the highest mark. Dahsyat juga orang Afrika ni So bubuk osas. So okay, kita rehat dalam 10 minit. Kita sambung balik dengan our class. Okay.
Baik.
Alright. Okay, kita rehat. Jumpa nanti. Sorry, apa attendance? Sekejap saya kena hantar attendance. Saya hantar attendance dekat chatbox Okay, so please fill up the attendance. Okay, kita sambung boleh? Can we start back our lecture?
Boleh sir.
Boleh sir.
Oh, okay. So before that, I think I missed several points that I need to highlight. So when we do the programming, right? So for example, in this case, I'm using C language. So before we can use the socket function, the bind function, and also the struct for the provide the address information, right? So before we done that, what we need to do first is we need to include the library which needed for the socket. So what we need is csocket.h and also arpa inet.h. These two. And of course, you also need other type of library which to help in your programming. For example, if we want to print out the terminal, to print the anything to the terminal, so of course we will use printf. So printf is part of UniSTD and STB standard library. All right. So for socket, these two things. Boleh tak? Ingat Okay, so we go back to our lecture. So after we have bind, okay, so we have TCP, then we have UDP, then we have TCP. So for UDP, diagram where it will have connectionless type of communication, and for UDP we doesn't need to bind, but for TCP we need to doesn't need to listen. Sorry, so for TCP we need to listen. Okay, so a connection occurs between two participants, which is server and client. So usually the passive one is the server, where it will wait for a request from the client. So kenapa the passive? Why it is passive? It is waiting for the client. Then the active one is the one that initiate the connection to the passive side. So the active one is the client, right? So once a connection is established, passive and active participants are similar so that they can send and receive data between each other, right? And there is no connection setup for the UDP. So untuk UDP, there is no, we doesn't need to connect and accept and also listen. We doesn't need to do that. For UDP, we can, after we get socket, we bind the socket, then we can straight away send and receive data. So I will show you the example of code after this, right? So again, UDP, we doesn't need to set up the connection. And since we doesn't need to set up a connection, so if we want to just send data, so we can straight away use send to function. We doesn't need to, do any binding. Okay, next, so this is how it do. So I already explained this. So for passive, it will listen. Then active will request a connection. Then the server will accept the connection. Then after that, we can do the data transfer. Okay. Right. So after we have bind, so we will talk about for passive participant, which is the server. So we will use the listen function. So what listen function do? So the listen function will return back a value which is in integer. So basically, it will send a status. So if the listening the socket has successfully turned into listening mode, it will send 0. So if it return -1, so there is an error. So we can check based on this value. And there is two parameters that we can pass to this function. So first, the socket descriptor. So for example, we already already create the socket, right? So we want to set the socket into listening mode. So we pass the socket descriptor to the listen function. Then after that is the queue length. So the queue length refers to the how many active participants that can wait for a connection. So for example, so if we want to create a server which able to cater 1,000 of user, so that's mean we need to set the value maybe 1,000 or 2,000, right? Because when we set this, the operating system will reserve some resources for that socket so that it can um, um, handle multiple requests from multiple clients. And listen is non-blocking mode, so that means it will returns immediately. So a process doesn't need to wait for the the listen process finish executing, right? So but for example socket accept, so the process cannot do anything. So that's why later on what we can do is we can use child process so that we can do some concurrent programming, because the other function is blocking function. So but for listen, it is non-blocking function. So let's see here from the coding here. So after we have bind, we send it listen. Okay, so dekat sini saya tak check apa-apa lah. So sebenarnya kalau nak check boleh je. So kita tambahlah variable here. So kita declare variable, so then we put variable there. So anyhow here the socket descriptor, the same one. And after that, so that's I put 3, so that's mean it can support 3 client waiting for connection, right? Then after that we can start to the server will start to listen to the connection from the client. So when we open up a client, okay, so for client, after we have create a socket, so for client we doesn't need to bind or listen, since this is that is for only for server for passive participants. So for client, what it can do is it can initiate the connection using the connect function here. So for the connect function, it will request a socket. Okay, so socket dia, socket descriptor yang kita create tadi, and the struct which contain the IP address of the server. So ini IP address server tu lah. So nampak tak? So now we doesn't use the in ADDR any. So doesn't mean that mean it will not send to multiple IP. So this is the specific IP of the server. See here. So this is the server IP. Highlighted here 192.168.114.6. So here, that's why nampak tak, kita kena convert from dot decimal point into the binary and big Indian. So kita gunakan inet ADDR function. So it will convert it this decimal form, dot decimal form into the socket form, right? To the host format, which is in big Indian. So this is how we connect it. So we put here and also the size of the struct. So once we have connect, so at the server, so if you guys have any questions, so maybe if I'm going too fast, so please do interrupt me and say that maybe you need me to re-explain some things that maybe not clear for you. Okay, so for server, so if we want, so we will usually, if we want to continue to listen to the client request, usually we will put the accept function in the while loop. So why we need to do while loop? So that means it will constantly listen for new connection from the client. So it just loop, right? So it will like dia akan ulang this one so while dia akan gunakan accept function untuk check. So after the client has initiate the connection using the connect function, so the server will use the accept function. So the accept function For the accept function, there is 3 parameter. So first, the accept function will return back a new socket. It will create a new socket, and basically that socket is used for that particular connection with that particular client and will be used for data transfer session, right? So that why we need to do this, as I told you before, so that the server can handle multiple clients. So that's mean if the accept function doesn't return back it doesn't return back a new socket, that's mean the socket can only be used by one client, not multiple client, right? So that's why every time it accept new connection from one client, it will create a new socket, and it will save the socket descriptor in it will return back, and we need to save it into any variable that we want, right? And next is for the parameter, we need to pass the socket descriptor from the socket that we create earlier, then also the name. So the name is basically we need to put a struct here. So this one, what it will do, the accept function will store the information of the client here in this struct. And also we need to put the size of the struct here. So maybe you can see the example here. So this is the server. So I declare the struct as C. C. So kita dah declare kat sini Okay. So this is the size. So kat sini dia simpan so dekat sini kita ada socket descriptor, struct tadi tu, kita akan simpan dalam client tadi, struct, dan kemudian ni dia punya size. Boleh juga guna size of, dan this is the new socket. Nampak tak? Kita akan returnkan the value of the socket for that particular client in the one variable. Okay? Can? So after we have create a socket, then we can begin the data transfer punya session. So here, when we want to receive a data from the client, so we put not the socket here, right? So kita tak gunakan socket this one. So this socket is for the main socket, but what we will do is we will use the new socket, which is used for the data transfer. Nampak kat sini? New socket, and also we will put a variable here so that the receive function will write the value that it received from the server into this variable client message, and this is the size of this buffer, maksudnya size of this variable. So we put 2000 here, so that's mean that it can support up to 2000 bytes of the data or value, right? Then if we want to write back into the client, then we can use the write function. We put the new socket, then the message. So I put here, this is the message that we want to send. Then the size of this variable. Okay, so if we open up the client here, the client, once we have do the connect function, so we can also use the send and receive function, same as the server. Question? So far so good? Can we see a demo? A simple demo?
Yes.
Right, so let's put it side by side. So left side is server, right side is the client. So let's compile the server. I'm using the GNU C compiler, right? So gcc server.c. Okay, so first let's run the server. So the server socket descriptor value is 3. So it's successfully bind to the IP and the port, and now it's waiting. So now we can use the client. So now compile the client, run. So you see, so what it do, First, the client will send a data to server. The server will read. So this is the data that it received from the client. Then it will print out to the terminal. Then after that, it will reply back this value, and the server in the client will print out to the terminal. So this is the data in a string. I'm sending the data. The data is a string. You can send all type of data type. You can send a string. You can send an integer. You name it, based on your design. So for example, if you are want to do file transfer protocol, so if you want to send a raw bytes data, then yes, please go ahead. You can send a raw bytes through this socket. So socket is just a way we can send data from client and server, right? So after the client already printed out the reply from the server, then it will exit the program. So really a simple example. Any question from you? Boleh tak? Question guys?
No, sir.
Right, ni paling simple lah. So satu lagi kita kena tengok juga is this one. Even though kita boleh create multiple socket, tapi dia bukan concurrent tau. Maksudnya sekarang ni dia hanya boleh handle satu client saja dalam satu masa yang sama. So maksudnya kalau kita tengok client ni pun, this is very simple form of communication. Nampak tak? Last kali tu kita gunakan closing function lah. Kita nak close the socket tu. Tapi sekarang ni server ni, kalau kita tengok daripada code ni, dia hanya boleh accept connection daripada satu client saja, walaupun kita ada create multiple socket here. Pasal kita tak ada create any concurrency, so kita tak ada buat fork dekat sini. Okay. Contohnya saya ada satu example. Saya ada create satu where I think okay, so first let me saya ada satu server kat sini where dia tak support concurrency. Okay, so kalau kita tengok kat sini, bila kita accept, dia dalam loop tu kan, tapi dia tak create any fork, dia tak buat any child process. Okay, so apa dia buat, dia akan terima data daripada server, daripada client, dan dia akan return balik data yang sama kepada client. Okay, so sekarang ni kalau saya run server saya ni, okay, ni tak ada ni tak ada concurrency. So maknanya dia simple macam kita belajar tadi. Kita buat socket. After we create a socket, we bind the socket. Then after that we listen. Dan kemudian we use the accept function. Then after that we send and receive. But since we doesn't use any child or parent process, we doesn't create multiple process, it can only receive or handle connection from one client. So this is a bad example lah. So contoh, so ini yang sama macam code tadi. So let me compile dulu. Okay, so dia tunggu dia bind kat port 444. So kat sini ada satu client. Okay, so contoh testing for class. Okay, nampak? Dia dapat server dapat. Nampak dia dapat IP client tu, port client tu. Kemudiannya dia akan return balik kepada client tu balik. Inilah eco server very simple one. Tapi since the server it did not been designed with multiple client in mind, so maksudnya dia tak ada fork ke apa, so dia hanya boleh support satu client. So contoh saya run satu lagi VM saya I want to run another virtual machine supaya Saya nak tunjukkan ada lebih daripada 2 klien. I hope that I have enough RAM. So yep, I will open up another VM. Okay, give it time to boot. Oh, by the way, as of now, do you guys have any question? Ada soalan tak nak tanya? Boleh lagi setakat ni?
Okay, sir.
Boot lah. Pasal walaupun saya punya laptop ni SSD, tapi kan kita buat satu virtual hard disk kan. So virtual hard disk tu dia dalam satu file. So dia tak boleh nak gunakan juga kelebihan SSD tu. So dia tak instant boot lah. Right. So now already boot. So I open up another remote terminal for my another machine. Okay, so left side ni semua saya punya klien time. Okay, so satu dah connect. So sekarang ni server ni dia still yang dia tak ada support concurrency kan, pasal kita ada fork. So sekarang ni, so saya ada satu juga, saya copy je sebiji sebenarnya code daripada ni. So saya compile klien saya, klien yang sama, ni sama je. Dia akan connect ke server yang sama pasal kalau dalam code ni dia letak IP server yang sama, .6. Maksudnya server lah. Saya compile saya punya this one. So now saya compile, so nampak saya connect. Boleh tak? Dia send apa-apa tengok, dapat tak? Tak boleh dia sebenarnya waiting. Pasal kita punya server apa? Ni boleh. This one tak boleh. Pasal dia nak try connect, so actually dia waiting. Dia menunggu server ni. So contoh kalau I try to exit this one. Dia buat control kan. Kalau saya exit kecil. Okay, so contoh if I exit, so let's try again. Haywire. So anyhow, nampak tak? Dia tak boleh nak support multiple client Okay, so now saya ada lagi one set of server code which I put fork, benda sama, right? The same thing, dia akan receive data daripada client dan dia akan return back kepada client. So dia adalah echo server. Okay. So dekat sini apa beza dia? Saya gunakan nampak fork. See here fork. So maksudnya bila kita receive, kita create a new socket. Sebab kita dalam while loop juga, kita accept, kita create a new socket. Kita akan, lepas tu kita akan create a fork. Kita akan buat satu child process. So child process tu, apa dia buat? Dia akan handle dia punya data transfer tadi tu. Nampak? Kita gunakan fork. Then this is the child punya ni. So nampak? If child equals to 0. Nampak tak? Kan child 0 kan? Macam we already discussed in the class before. So here is the child punya code portion. So now, if I run this code, kalau nak saya share code untuk child apa yang untuk multi-process ni, later on saya boleh share dengan kamu just minta saja, nanti saya boleh share code dia. So anyhow tak apa, dalam lab pun sebenarnya kamu akan buat guna multi-threading untuk buat concurrency ni. Tapi kalau nak minta ini juga boleh, no problem So anyhow, saya ada server, saya run balik. So sekarang ni, saya run saya punya client. Okay, dia connect. Testing client 1 for example. So kita, tadi tak boleh kan? So sekarang kita akan, nampak? Kita boleh dua. Nampak? Connection accepted from another one. Nampak? So kita hantar juga. Nampak? Kita dah boleh buat concurrent. Nampak?
Nampak.
Yes. So this is apa yang kita nak lah sebenarnya. Right? That's why earlier in this class, kita ajar. So I teach you guys how to use fork function so that we can have kita boleh handle multiple client. Right? So anyhow, kalau mungkin I can open up another instance of my server here. If we see the background process, right, we can see there is a multiple process being created. So apa nama dia? A.out tadi kan? Okay. So if we use PS, AUX, grab A.out. Ini nama program ni A.out. Kita run dia A.out. Okay. So kalau kita tengok ni, see, we can kita ada berapa child tu? Ada 2 child kan? Ada 1 parent. Ada 1 parent, lepas tu ada 2 child. So setiap child tu dia akan handle each individual client. This is what we want. We are using the fork. Right? Any question guys? Boleh? Can ah? Alright. Tak apa, digest dulu, nanti kita akan buat dekat lab. We can discuss this in more details during the lab session. So anyhow, the set function is, oh by the way, I hope that you guys aware. So sekarang ni, the communication, even though it happened just in my laptop, right? But the same thing apply if you are using it to the internet. So that's mean if you have server in data center and if you have a client maybe at home or anywhere, as long as it's connected to internet, this is the same thing. This is the same principle applies, right? So that's why we are simulating the network, right? The communication here we are simulating. So this all of this VM is communicating via a virtual network. So that's why we are using VirtualBox, right? So that if later on, if we want to deploy it as a production in the data center, the same thing applies. But the only thing that we need to change is the server need to have public IP lah, bukan private IP, right? So we need to have a data center provider or cloud provider which able to provide our server with public IP. But other than that, this is production already. You can use the same principle if you want to create your own protocol, your own program, your own online game. So this principle apply, the same principle that you learn today. Okay. Right. So this is connect function. I already explained to you. So for the listen and accept, this is only for the server side. So for UDP, we doesn't need to use listen and accept. Sending data and receiving data. I already also explained this to you guys. Okay. All right. So that is we are sending and receiving data using TCP-based connection. How about if we want to send a data using a UDP without a connection? So instead of we using send and receive, we can use send to and receive from. So this is for the UDP based connection, right? So yeah, let's see examples. Let's end this server. Okay, so I think I have another set of code. Maybe I can show to you, which I think I put a UDP. Yep. UDP, let's see the server code. Okay, so this the UDP server, first we create a socket. We bind it to which port and to which IP address. Okay, but see, we doesn't have listen. We doesn't have listen. So we can straight away using receive from and send to function to send and receive. So there is no prior session being set up. So there is no connection oriented session being set up. After we create a socket, after we have bind it, then it ready to receive and send data. So there is no three-way handshake. But when we use UDP, even though it is efficient, there is no guarantee or mechanism for the server to ensure that the data being sent and received has some acknowledgement. So maksudnya server dengan client tu dia tak ada no way nak tahu, server tu nak tahu data tu memang sampai ke tak dekat client. So this is nampak, dia receive from, send to. So saya pun ada code dekat sini. Let's find for the UDP. Put here somewhere. Yep. Okay, so here for the client, so we just create a socket. Then after that, we can start to send to and receive. Right? So let's see. Let's compile this. Okay, binding. Let's make sure that this is the correct IP of the server. Okay. Okay, so this is, we are sending via UDP, not TCP, right? So this is UDP. There is no prior communication being set up. Okay, so this is UDP. Any question, guys? We will do it more practical during our lab session. So you will have your hands-on exercise when you want to create a socket programming using TCP and also UDP. So that we will do in our lab session. Okay, and as I told you before, I also has provide you with a reference book which is in socket programming. So please do refer the books so that you can have better understanding about all of this function. So guys, any question? So far so good?
Okay, sir. Okay, sir.
Kita boleh try apa sekarang ni digest dulu, fahamkan dulu macam saya terangkan tadi TCP, apa teori dia, macam mana kita nak buat. Tapi of course if you want to have your skill set, you can do your programming. There is no other way than you need to do it yourself. So that's why we have our lab session. Okay. Okay, after this, this is the close function, right? And yep, as I told you before, we will have we can convert the little Indian to the big Indian. So in that examples, for example, if I especially when I'm using the port, so the port, since I'm using Intel PC, so the variable is being stored in little Indian format. So if I want to use the socket, I need to convert it. So I need to use host to network. So that's why in our code that I told you earlier, example here, for the port, okay, so the port number is 8080. So for the port, I will use host to network, short. I can also use host to network long, no problem. but usually this is adequate. So this is, we are converting from the Little Indian, which is for Intel processor, into the socket, which is the Big Indian. But if we are using ARM based processor and also Motorola, we doesn't need to do this actually, right? But since most of our laptop here is using 886 platform, we need to do this. Okay. Okay, is it clear?
Yes, sir.
Alright.
Yes.
Yeah. So S and L ni beza dia just long, short and long. For short, it is 16 bit, 16 byte, and this is for 32 bit, 32 bytes. Okay. Right. This is example how we going to convert. Okay, ni saya tunjuklah dekat coding tadi. So tapi kalau if you guys want to refer to the slide, you can please go ahead. Dan dalam book pun, dalam our reference book, there is a lot very detailed explanation about the conversion. And next is another conversion, right? Yeah. So the IP address is in decimal form. So this is in the dot decimal form. Even though it is 32 bit, IPv4 is 32 bit, right? So it is in a dot decimal form. So if we want to use a socket, we need to convert it into the network. So that's why we need to first convert into the network form, and we need to convert it into the Big Indian. So maksudnya apa it will do is it will convert address from a dot and number string to the struct format. Okay, pasal kita nak masuk dalam struct So what we see here, let's open up the client. Let me shut down this. Okay, so this is the client code. I think I put the server. Yep. So since we are binding the IP, right? So for the bind, so we need to set a struct, right? So here, you see, we are using the INET ADDR so that we can convert the dot decimal format into the format which is compatible with this struct, the INET.h, this one. We know INET.h format in the struct. Okay, we are using this. So what it do is, it will first convert it into the struct format, then it will also convert it into the Big Indian, since socket are using Big Indian format, right? So this is all about. Okay, so convert, so you can read on your own. Okay, this is the return value. I already show you the example. Okay. All right, so I think that's it. So any question for you guys? So I think that's cover all of our lecture for today for using Unix API. So question guys. So anyone have any question, especially the coding part? Anyone want me to clarify anything? So feel free to ask me any question.
No, sir.
Right. Okay. Right. Alhamdulillah. So now how about, okay, so before we end our class, right? So how about we play some game also, Kahoot, so that I can gauge the level of understanding all of you, right? So Kahoot. Okay, so please you can open up www.kahoot.it and put the game pin so that you can join the game. Okay, jom. Which of the socket function return a peer info? Get peer. Oh, I think saya tak ajar lagi ni. So basically this is ni untuk next week ni lesson ni actually. So tak apa lah, ramai betul kat tu sebenarnya. Get peer ni betul eh. So basically this is an advanced socket function which we will learn next week actually. But anyway, since you guys already answer this, good. Next. True or false, set socket option, manipulate the parameter of socket. So also this is also advanced socket function. Yep, the answer is true. So when we want to use the advanced socket function, which we will learn next week, so there is a one function where if we want to set, we want to manipulate the parameter of the socket. For example, if we want to enable keep alive, so we can use this function, right? Seems like many people okay, the answer is get host by name. Apa ni sebenarnya ni advanced socket function. Tadi saya silap pilih Kahoot ke apa? Olah, kita habiskan je lah kan. Dan nak habis kelas dah pun, tak apa. Ini somehow preview lah untuk next week True or false, get socket option, return a value from service file. So it's false. Dia sebenarnya daripada etc slash protocol, tak silap. Okay, tak apa, jangan risau. Tak salah, tak apa. Next, last one. What is the value returned by get served by pod? Upon the pod lah, pod given from ETC services. Right. Walaupun tak belajar lagi, kita belajar minggu depan. So anyhow kita tengok siapa yang okay, RERSL paling tinggi. Right, thank you for your commitment kerana join game ni. Thank you very much. So I think that's all for our lecture today. So oh, by the way,